An interesting question. Why do rings appear around some planets, such as Saturn, while others, such as Earth or Mars, do not have rings? As it turns out, the size of the planet does not play a role here. Rings are found in giants and even in asteroids. An example of the latter is the asteroid Chariklo, with a diameter of about 260 kilometers, which last year the space telescope Spitzer found two rings at once. The answer to this question, at least roughly, there is an answer. Near some planets have historically turned out to be little dust, and near others, a lot. Dust particles gathered together, formed particles that continued to grow and got bigger and bigger, which is, of course, understandable. But why did the growth of the particles suddenly stop when they reached the size of a house? That was the mystery. Moreover, the size distribution of particles itself followed a beautiful mathematical law of inverse cubes, which means, for example, that particles of size 2m are 8 times smaller than the last particles of size 1m, particles of size 3m are 27 times smaller, etc. The nature of such a law also seemed mysterious. Saturn's rings are a majestic sight. They consist mostly of ice crumbs, with a little mineral matter, and extend for hundreds of thousands of kilometers. At the same time, the thickness of the rings, that is, their size in the other perpendicular direction, is only 10 meters. In this sense, Saturn's rings are millions of times thinner than the sharpest razor. In addition, all this icy mass is carried around Saturn at a colossal speed, 72,000 kilometers per hour. This is the so-called orbital velocity at which the particles move as a unit. Nevertheless, the speeds of individual particles do differ slightly from this average speed, but on average these deviations are negligible, on the order of a few meters per hour. When the particles fly toward each other at such low velocities, they come together and cannot fly apart again because of surface forces, an effect similar to the way two snowballs stick together if they are forced together. This process of sticking particles together happens all the time. However, there is an opposite process of particles breaking up in collisions. The point is that a very small fraction of particles have very large deviations from the average velocity. If such a fast particle crashes into its neighbor, both particles are crumbled into small pieces. This happens very rarely, but eventually a balance is struck between particle unification and disintegration. Scientists have built a mathematical model of these processes, which was investigated by various methods, including numerical solution of a huge number of differential equations. This could only be done on a supercomputer. As a result, one of the most powerful supercomputers in Europe was involved. Scientists explained as the absence in the rings of Saturn particles larger than a certain size, and the mysterious law of inverse cubes. Moreover, from the obtained model followed and such an important conclusion that these patterns should be observed for all rings, whether it is a ring of a planet or an asteroid. This work allows us to make a number of other scientific conclusions. For example, on the mechanism of formation of rings and their evolution. In particular, the results of scientists say that the rings of Saturn are in a stationary state. This means that the dinosaurs observed, if they could observe, the same rings as they do now. The same rings will be observed by our descendants. Moreover, since the characteristic time of change of rings under the influence of any external influences does not exceed 10,000 years, it also follows from the model. Nothing catastrophic has happened to the rings since the Bronze Age. For a long time it was believed that a careless satellite approached Saturn and was torn to shreds by its tidal forces. But Voyager data has disproved this popular belief. It is now established that the rings of Saturn, and other planets too, are the remains of a huge near-planetary cloud with a length of many millions of kilometers. From the outer regions of this cloud, satellites were formed, and in the inner region, the formation of satellites was completed. Since the velocities of mutual collisions increase as they approach a planet, there is a region near each planet where particles, having reached a certain size, begin to collapse from mutual collisions. Billions of years of collisions, and 10-meter particles have reached such a friable state that they fall apart from the slightest jolt at a speed of ms. Any large particle goes through a complete cycle from destruction to recovery in a matter of days or weeks. This mutual competition, which prevents the formation of large satellites, weakens with distance from the planet. And at some distance, part of the matter becomes satellites, and part still remains in a fragmented state, in the form of rings. By the way, the rings have already made 1 trillion revolutions during their existence, much more than the satellites or planets in their orbits. The total mass of Saturn's icy rings is comparable to the mass of its satellite Mimas, with a radius of 200 kilometers. Why are the rings flat? Their flattening is the result of the opposition of two main forces, gravitational and centrifugal. Gravitational attraction tends to compress the system on all sides, while rotation prevents compression across the axis of rotation, but cannot prevent it from flattening along the axis. This is the origin of various cosmic disks, including planetary rings. Thank you for watching this video to the end. Don't forget to like and subscribe to the channel. See you soon.